Although optical fiber is the newest medium for transmitting data, optical wireless transmission is one of the oldest. Humans come equipped with a modem-like organic device that receives light waves and converts the electromagnetic radiation to electrical signals, which are processed in the brain. It's called vision. Electromagnetic radiation in the visible light range is the only radiation that people are normally able to see. Because of the particular properties of visible light waves, they can't pass through most objects, so strict line of sight is required. In addition, the ability of the eye to detect light waves decreases with distance. These two things limit the practicality of vision as a long-distance communication medium. In 1870, John Tyndall demonstrated that light could travel in a stream of water, even if it was curved. This is possible because the light waves bounce back and forth off the transition between the water and the surrounding material, thus stay confined to the tube. In 1953, the physicists Narinder Singh Kapani and Harold Hopkins transmitted a high-quality image through a bundle of glass fibers. Even clear materials are full of impurities that block light waves, so at first the light waves could only travel a few yards. Improvements in the purity of the glass strands greatly increased this distance. Because of the short range of visible light, fiber optic transmission uses longer wavelength infrared radiation for long-distance transmission. People can't see infrared light. Special lasers generate it. Despite efforts to keep the signal from decreasing too much in strength, lasers are also needed along the route to amplify the signal. All data, whether wireless, copper wire, or fiber optic, is transmitted on electromagnetic waves traveling at close to the speed of light, not by electrons or electricity. Fiber optic cables carry large amounts of data because the frequency of the visible or infrared radiation used in fiber optic transmission is many thousands of times greater than the frequency of the radio waves traveling wirelessly or on copper wire. Higher frequency means a wider band, thus more data can be moved per unit time. Fiber optic networks can be used in conjunction with low-cost radio frequency wireless networks for last-mile transmission. Newport Wireless Mesh, a 501c3 nonprofit, is one such network, providing wireless internet service from a fiber optic gateway to our low-income neighborhood in northern Vermont. Find out how you can help support our efforts to develop efficient, low-cost wireless networks in the description below, and be sure to like and subscribe. Fiber optic networks differ in several ways from copper wire or wireless networks. Instead of a modulated wave, fiber optic transmission uses a digital on and off code representing ones and zeros. When the light signal gets to a device in the network where direction of traffic takes place, the signal has to be converted to an electrical signal for processing and then back to light to continue on its way. Because this can slow things down, devices have been developed that process the data entirely as light. Like early telephone transmission, fiber optic networks use permanent circuits for sending data. Protocols similar to packet switching are also used to increase efficiency. The amount of data that can be sent through a single optical fiber is further increased by sending multiple signals at slightly different wavelengths, called multiplexing, a technique also used in copper wire networks. Fiber optic communication uses several strategies to send the greatest amount of data per unit time of any medium currently in use, though it is also the most expensive. Internet service providers and manufacturers hope that fiber optic networks will provide the bandwidth consumers will need not only for home and business internet, but also for the many Internet of Things devices that will be marketed in the future.